Objects are constantly in motion all around us, yet it is often difficult to measure even the most basic physical properties of moving objects in real time, such as their velocity, acceleration, or turning angles. Fortunately, there's a freely available software called Tracker that lets you measure the underlying physics of motion for anything you're interested in. All you need is a computer and a video of the motion that you'd like to investigate. This video of a basic baseball bat swing will provide a brief demonstration of using Tracker to create the track of an object moving through space and time. This track will allow us to measure velocity, acceleration, angular rotation, and many additional physical properties of motion.
The first thing we're going to do is look at some video properties. These are the XY coordinates of the video, the frame number, the playback speed, beginning, playing the video, and sliding the video to different steps. Of course, speed is distance over time, so we need to calibrate the video. So using this measuring stick I'm holding up, we're going to calibrate it to 1 meter. So we drag the two tips to each end of the meter stick, type in 1, and now the video is calibrated. We're going to hide this meter stick so it doesn't get in the way of our future measurements. Using this arrow, we're going to drag all the way down to the swing because we don't want to measure anything before then. Okay, now that we have our starting position, we're going to create a track. We click Point Mass, and we're going to name this what we're going to track, the bat tip. We'll zoom in to get a better position of what we want to track, and by holding the Shift button, we will click each point we want to measure. The frames will step forward automatically as long as we are holding down the Shift key. So from then on out, it's very simply just clicking every point in each frame of what we want to track. On the right, you'll notice a graph being generated as well as a table with the data that we are trying to find. We have now marked all the steps on the bat tip, and we'll reset the video. I've repeated this process for 3 different positions on the bat, and now we will look at the velocity vectors of all 3 positions on a single video. If we expand the graph and table from the right, we see the 3 different tracks on the graph. The red is the bat tip, the yellow is the bat middle, and the green is the bat by my hands. We see that peak speeds occur at step 12, which hopefully would be when the bat would be making contact with the ball.
This was just a simple example of using Tracker to measure the motion of a swinging baseball bat. You can use Tracker to measure the physics of motion on any moving object, so get creative.